Hey everybody, Mr. Bucko here with problem number 9 from your Part 2 practice test from Chapter 8, where we are simplifying the expression the square root of 8 times z squared times y to the third. What makes this one particularly tricky is this y to the third, and also we have this 8 that we're going to have to deal with as well. So I'm going to put this up here. We have square root of 8 times z squared times y to the third. If we're going to take the square root of any term, we have to kind of separate the factors, separate out all the bases. So if I do that, what we get is this. So all I've done here was just separate each of the terms into kind of their own square roots, because we can do this. We can separate the factors from the term into their own square roots. So that's what I've done here. So I can evaluate each of these independently and then put them together at the end and find out what that square root is. So first we see the square root of 8. I don't know what the square root of 8 is, because 8 is not a perfect square. So I can't say that that's 2 or 3, because it's not 2 or 3. It's some decimal that's in between 2 and 3. So what I have to do is take this 8 and break it down into perfect squares, if a perfect square goes into it. And a perfect square does go into 8. 4 goes into 8. And 4 goes into 8 twice. So I can rewrite this square root of 8 as the square root of 4 times the square root of 2, because 4 times 2 is 8. So this has been broken down into the square root of 4 times the square root of 2. And I'm doing that because I can evaluate one of these square roots, which we'll get to in a moment. So we're going to leave this as is for the time being, and we're going to move on to the square root of z squared. The square root of z squared is z, because z times z is z squared. If I take the square root of z squared, I get z. And then I have the square root of y to the third. And that rule for taking the square root with an exponent is that you divide the exponent by 2, kind of like we took this 2 and divided it by 2. And got a 1, so there's kind of a 1 there. That's an integer, but we have an odd number now, so that's going to be a little problematic. We don't want to say y to the 1.5 because we do not want decimals as our exponent. So I'm going to break down y to the third, much like I broke down the 8 into perfect squares, and we can rewrite y to the third as y squared times y, because y squared times y is y to the third. And now I can evaluate one of these square roots, which we'll do in just a moment. So I've started with this square root here, this expression, broke it down a little bit, broke it down even more, and it's funny because it says simplify the expression, even though it looks like it's getting more complicated, but we're just asked to evaluate what we can evaluate. And there are things that we can evaluate here now with this line. I know what the square root of 4 is. The square root of 4 is 2. So I can rewrite the square root of 4 as 2. The square root of 2 I don't know, because 2 is not a perfect square, and there are no perfect squares outside of 1 that go into 2, so I just leave it as a square root of 2. It's an exact value. I'm not going to write a decimal. Then we have the z, so the z is still there. That doesn't go anywhere. I can't really simplify z at all. There's nothing to do. Then we have the square root of y squared. The square root of y squared is y. And then we have the square root of y, which we cannot evaluate because I don't know what the square root of y is, because y is not a perfect square and there's no number that's representing y, so I have no clue what that could be. So we leave it as the square root of y. So now we've evaluated everything that we can evaluate. There's nothing to be evaluated anymore. I don't know what the square root of 2 is. I don't know what z times y is, or y times the square root of y. There's nothing else to do except for kind of organize this stuff a little bit. And we can kind of do that reverse process with the square roots. I can take what's inside the square roots, and since I'm multiplying them, I can just put them underneath the same square root. It's the exact opposite of what I did from the start here. So I'm going to kind of organize this a little bit. I have the 2 times z times y, because I have 2 times z times y, which give us this 2zy here. And then I have this square root of 2y, and the 2y is underneath the square root because I'm taking the square root times the square root of y. So I can rewrite it as the square root of 2y. So this whole mess here, if we evaluate what we can, it becomes 2zy times the square root of 2y. And again, it says simplify. This doesn't really look any simpler than what we started with, but we have evaluated everything that we can evaluate. There's nothing else that we can do with this. We can't break this down anymore or do any more simplification because we've evaluated all the square roots that we possibly can. So the correct answer here would be C.